HCR 130, EQs, wire sizing, and safety sizing, we deal with the wire sizing guide that, if you remember, you can go to Teams, and if you click your Teams, you should have a team entitled, what did I call yours? Freshman Spring 2021. If you click on that team within Files, you have all kinds of resources for troubleshooting. I'm adding to them as we learn a little bit. Some of them you haven't learned yet. But in this, you can find a wire sizing guide. So let me see. And an electrical cable chart, by the way. I'll use one or the other. And the multimeter. Let's use this one. Alright. So when we talk about wire sizing from the NEC, you have to first understand what type of wire you're dealing with. Are you dealing with solid conductors? Are you dealing with stranded conductors? Are you dealing with indoor color-coded wiring? Are you dealing with outdoor wiring? Are you dealing with aluminum wiring? Do you have mobile home feeders, which are aluminum? Do you have, and what gauge and how many conductors? So for example, on the wire itself, you'll find a listing such as 14.2. What does 14.2 say? It's 14 gauge, 2 conductors, 2 wires to flow electrons, and 1 ground. So 14.2 will have 3 wires. The white and the black are conductors. The bare wire is the ground. Compared to 14.3, which will have 3 conductors and a ground. So you'll have 4 wires total. You also need to be aware of what amp draw is suitable for which size of wire. And there's a reverse correlation. The smaller the number of gauge, the bigger the wire. So for example, 2 gauge is much bigger than 14 gauge. Here's 1 2 gauge thickness. Here's 3 14 gauge thickness. Then you even have thermostat wire, which is commonly 24 gauge. You know how thin thermostat wire is. Sorry. So there's a reverse correlation. The larger the gauge, the smaller the wire. Keep that in mind. Back to our questions. When sizing safety and wire for appliance equipment, why is it essential to do so correctly and according to the National Electrical Code or UL standards? So you don't kill somebody by not properly grounding your equipment, or by burning a house down by undersizing the wire. Okay? We'll get into details, more variables that affect your wire sizing, such as length of the run. But in Teams, always remember you have this chart available to you on your phone at all times. And you should save it to your OneDrive and take it with you as you graduate and pull it out of your pocket anytime you need it. Okay? Back to our assessment. It is very important that you size it correctly and that you ground it correctly. Why is it essential to size it correctly? Because if not, you can create a fire. Too small a gauge with too high a current creates heat that can melt down the insulation around the wire and catch any combustibles around that wire on fire. Electrical fires are very common and very dangerous. It's usually due to 2 reasons: undersized wire for too big a circuit, or overdrawing the amperage on the circuit, or loose connections. When considering an electric box, what is the most essential safety practice? You must lock out, tag out always. Lock out, tag out always. Domestic electrical services typically are one of 2 sizes. What sizes are they? They typically come in a 100 amp service for your smaller homes or garages or man caves or she sheds, or 200 amp services. And some buildings can have multiple services. And domestic services are typically single phase, not three phase. What is the data tag and what type of information can you learn from a unit? Oh man, we gotta wait. I gave 10 points on this question because it's a big one. A data tag is required by law to be posted on each individual appliance, and it tells you some important information. What supply voltage should be applied to it, what the amp draw is, what the lock rotor amps are, what the run load amps are, what type of fuse it needs, the size of the fuse, does it have a fuse, etc., etc. Model serial number are a big one. From that you can look up warranty information. But all kinds of information can be gained from the data tag. Let me see here. I know I saved you a data tag somewhere. I just don't remember where. I'll find it later. Keep it moving. You will have data tags on your midterm, and you'll have to be able to answer questions based on the tags I provide you. So if you haven't mastered them yet, take a moment. Let me help you a little. What does LRA on a motor or appliance tag refer to? That's your lock rotor amps. If the motor or the rotor stops spinning due to resistance and it overamps, this is the max amp draw you're going to get, and this is your load road amps or your inrush current at startup. So at startup, your amps are going to go way high, 4 to 6 times higher, and then if it locks up, it's going to overamp. What is RLA on a data tag? That is your run load amps. Run load amps are what the amp draw should be on any motor, any compressor, when it's running full speed. It should never go over it by 1/10. Say your compressor is rated for RLA for 11.2 amps. If while it's running, you put your amp clamp on it and you're running 11.3 amps, it may take a long time, but it's going to overheat and shut down. So your run load amps are the max amperage that motor, that load should draw while under a load, while it's doing work. How do you determine the fuse size and the wire size? By the run load amps. So if it's meant to pull, say 11 amps, you can't use a 10 amp breaker. You can't use a 10 amp fuse. You would upsize it slightly, say to 15 amps. Or if it's a control board and it uses 2 amps, you would put a 3 amp fuse on it. If it uses 3 amps, you would put a 5 amp fuse on it, etc., etc. Any questions about those EQs? Any questions at all? Okay. Just note on your midterm, you need to have a basic understanding. So I could give you a data tag to say an air handler with a 15 kilowatt heat kit that pulls 63 amps, and you should be able to tell me what size wire it needs, right? You should be able to look at that and say, well, it pulls 63 amps, so I can run a 4 gauge, or I could break it up into a 10 and a 6 gauge wire. So I can run 40 amps on a 6 gauge and 23 amps on a 10 gauge. You should be able to size a piece of equipment based